On today's call, I want to talk about the intersection of energy production and its influence on health and on healing. And if you're live on this call, then you're an active patient of mine. So we've talked about the importance of energy production biologically and how if we can't make energy, it's hard to heal from anything, and how energy production is one of the most overlooked physiological processes in conventional medicine. And by that, I mean, you go to your doctor, you have a 7-minute visit, and you leave with a medication, and they oftentimes don't consider energy producing processes in the body because they're looking for a diagnosis and sending you out the door. But if I say you have diabetes, obviously diabetes is an energy deficit disease, right? You can't deliver glucose to the cells. Well, if your cells don't have glucose, how can they run their processes and heal? Well, in the same way, if your immune cells or any cell in your body can't produce energy well, you're not going to be healthy and you're not going to heal. And so today I want to show you how energy production specifically influences immune system health and function and your ability to heal from whatever may perturb the immune system. But in general, this conversation, the biochemistry I'll show you, applies to all cells. So this is the energy process we want to look at. And so what we have here is a T cell, and T cells are part of the adaptive immune system, which is the more nuanced part of the immune system. We have an innate immune system, which we've talked about in other videos, where I liken the innate immune system to the local police or the fire department, first responders. And then the second side of the immune system is called the adaptive immune system, and that is more highly trained. That's like the SWAT team, and that includes B cells, which make antibodies for us, and T cells here, which are the main killers. And there's different types of T cells that have different jobs, but for today's purposes, we'll just keep it to T cell in general. And inside the T cell here, you can see in black is the nucleus, and inside the nucleus, I've drawn a DNA strand so that the nucleus is where the DNA is housed in any cell, but in this T cell. In green, we have a singular mitochondrion, but in this T cell, there's hundreds of mitochondria, which is mitochondrion plural. And we've talked about in other videos that the mitochondria is where our most efficient energy production is occurring. And we'll talk about that more today. But mitochondria are key in immune function, in inflammatory status, in health, and in healing, because they are going to provide the energy for the T cell to be able to kill an infection or clear a tumor or whatever it is we're talking about. Now, in the blue dots here the blue dots themselves are not anything. They're representing what's called the cytosol or the cytoplasm, or the liquid filling of the cell. Okay. And the reason I distinguish that instead of a bunch of other organelles that I'm leaving out, just to keep this picture pretty clear, is because if you're in the cytoplasm or you're in the mitochondria, that's going to make a big difference in your energy production, or more specifically, if the glucose or the sugar is in the cytoplasm or transported into the mitochondria, that makes a huge difference. So if we start with the cytoplasm, if we zoom out here, okay, let's pretend that we have some glucose. What color do I want to make glucose? Let's make our energy orange. Okay, so let's say we have glucose or sugar in the cytoplasm, and we want to follow its journey from being sugar in the cytoplasm to becoming ATP that this T cell can use to do its job. And so glucose out in the cytoplasm is going to be converted to pyruvate, and then it can go one of two ways. Okay, if we follow what happens in the cytoplasm, it goes through what's called glycolysis, And glycolysis can be aerobic or anaerobic, which means there's either oxygen involved or not involved. But the end result of the glycolysis process is you get two ATP molecules. Okay, and ATP stands for adenosine triphosphate. ATP is the literal energy currency of our body. Okay, so when we talk about we need more energy, we're talking about we need more ATP. So getting glucose into the T cell and metabolizing that glucose into ATP in the cytoplasm is going to yield 2 ATP through a process called glycolysis. Whereas if we take the same glucose molecule and we transport that from the cytoplasm into the mitochondria, now that glucose is going to go through a different pathway. It will be turned into pyruvate first, but then that pyruvate is going to enter what's called the Krebs cycle and then finish when it goes through the Krebs cycle. It's going to finish with aerobic, or this whole process is actually called aerobic respiration. Sorry, it'll finish with oxidative phosphorylation. And it's going to yield between 36 and 38 ATP, which is energy like we talked about before. And so as you can see from this drawing, sending our sugar, our glucose into the mitochondrion to be metabolized through the Krebs cycle is going to yield, 18 to 19 times more energy than if we metabolize that glucose into ATP in the cytoplasm. And what determines if the glucose goes into the mitochondria and goes through the Krebs cycle versus going through glycolysis are various factors. And the purpose of today is to show you that there's two different ways it can go, and one is clearly more important and produces much more energy for us using the same input. And so aerobic respiration is key. We want the aerobic part, we want the Krebs cycle part, because that's going to give us 18 to 19 times more energy. And the more energy we have, okay, the more healthier we can be. So the more healthier we can be isn't the best way to speak. Apologize, let's spell this right. Okay, so we could look at health as being the amount of energy we have. So the more energy we have, the more health we have. The more health we have, the more energy we have. And then healing is also going to be dependent on the energy we can produce. Okay? And health and healing are interconnected, of course, because the healthier we are, the better we are at healing, and the better we are at healing, the healthier we'll be. So we need the energy to do the healing so we can be healthy. Well, healing is referring to healing from a wound or a surgery. That could be healing or preventing cancer. That could be healing from infection or clearing infection. That's healing or preventing any chronic disease. Okay, so you'll hear about things maybe in blogs, or if you're reading research, you'll hear about mitochondrial dysfunction. And if you have dysfunction of the mitochondria, okay, now you're not producing this super efficient form of energy. So now what we have to rely on is glycolysis, and we're going to heal at a much slower rate, right? Because this is 1/18 of the energy that we were getting up here from the mitochondria. And so now maybe our wounds heal slower, maybe cancer gets a hold of us, maybe we have a chronic infection or a chronic disease. And so research is finding that mitochondrial dysfunction is at the base of many, if not all, chronic diseases, from autoimmunity to cancer to chronic infection. And so addressing the mitochondria is going to be key for health and healing and restoring mitochondrial health so that we can restore full body health and healing. And so strategies that promote mitochondrial health are going to be very important in preventing cancer, preventing chronic infection, autoimmunity, helping us heal from wounds or surgeries faster. And there's many strategies that can help us do that. And those include optimal nutrition, right? Exercise, and the best exercise for promoting mitochondrial health is zone 2 aerobic training. And weightlifting also will increase mitochondrial levels. We want to optimize sleep. We want to optimize stress. And we want to avoid toxic exposure and minimize toxins, because there are many mitochondrial toxins in our world, from glyphosate to statins to all kinds of many medications are mitochondrial toxic. So there's lots of ways that we can take action to impact this today and to promote the health of our mitochondria and our overall health. So I wanted to give you this foundation to now show you a very recent study that adds support to the mitochondrial theory of cancer. So let's jump over to that research paper. And here we are on this research paper that was published in October 2023 in the journal Nature Communications, and it's entitled Mitochondrial Dysfunction Promotes, and I'll shorten it to, exhausted T cells. You can see the whole title there, but the main point for this video is, and the main point of this paper is, that mitochondrial dysfunction promotes exhausted T cells. Well, you can see in the first line in red, T cell exhaustion is a hallmark of cancer and chronic infection. So if our T cells are exhausted, how well are they going to do their job of surveillance and clearance of tumor cells, rogue tumor cells, or surveillance and clearance of either novel viruses or chronic viruses or common viruses like Epstein-Barr virus, cytomegalovirus, shingles, herpes simplex 1, etc. So mitochondrial dysfunction promoting exhausted T cells could be behind your chronic Epstein-Barr, could be behind your cancer. Okay, and this paper is showing it is behind those things. So mitochondrial insufficiency is a trigger that initiates the exhaustion of T cells, and losing our T cells depletes our immunity, and depleted immunity is going to open us up to whatever our weak link is, whether that's cancer, infection, self-tolerance. So if you lose self-tolerance, now you're at greater risk of autoimmunity or autoimmune flares, maybe food reactions. There's all kinds of potential impact here. And so I'm not going to dive into this paper deeply. It's a great one. It's a long one. I encourage you to read it if this is a topic you're interested in. But I just wanted to show you that this is deeply researched material and very important to overall health and healing and function. And mitochondrial health is something that needs to be considered more in the mainstream. So rather than addressing symptoms and giving you a drug to address symptom that actually is mitochondrial toxic and going to drive you worse, why not take a step back and say, hey, how are the factors in this person's life that influence mitochondrial health? Again, all the things we talk about all the time: nutrition, physical activity, stress reduction, sleep hygiene, toxin avoidance, etc. Sleep, I said that, etc. So hope this was enlightening for you, and I'm going to flip back to the drawing and open it up for questions here.
Do you want to speak to getting into the zone 2 aerobic workouts?
Sure. So what is zone 2 aerobic exercise and how do you get into it? Good question. So zone 2 is part of heart rate training, and essentially heart rate training is breaking your heart, is understanding what your max heart rate is and breaking it up into 5 different heart rate zones. And the zone 2 heart rate falls into the 60 to 70% of your max heart rate area. And so zone 2 exercise is something that's sustainable. Essentially, you should be able to do it nonstop and maintain it. So you could think of it as conversational pace, or a little more than conversational. So maybe you're exercising and trying to talk, and you can talk like this, not that comfortable, but you could still have the conversation, right? And so how do you figure what your zone 2 is? The best way scientifically would be to go have a VO2 max test done, but that's can be expensive and hard to find. And so the easy way is to take a calculation and figure it out. And so that calculation is to do 220 minus your age. And so we'll do mine. So I'm 41, so 220 minus 41 is 189. Okay, so 189 theoretically by this calculation would be my max heart rate. And then what you want to do is you want to exercise within 60 to 70% of that max heart rate. So for me, 189, so call it 190 for easy math. So 19 times 6 is 60, plus 9 times 6, 54. So 114. So 114 then plus 19 would be up to the 70%. So that'd be 133. So for me, my zone 2 heart rate is 114 to 133. Okay. And so I could set my Fitbit or my Apple Watch or my Polar chest strap, whatever technology you have, you could set alerts on that technology, or your elliptical machine, if your machine does it, and you set it to say, I want you to beep at me if my heart rate goes below 114 in this workout or above 133 in this workout. So if it beeps at you, you've either dropped too low and gone easier or gone harder than you want to go for zone 2. We want to stay in here. And the research shows that zone 2 exercise is the best exercise there is for cardiovascular health. It promotes mitochondrial health, and there is no upper limit discovered to this point in 2024 where you could be doing too much of it. And that's different from weight training. For weight training, they found that you don't want to do more than 150 minutes a week, which is 2.5 hours a week. Same for boot camp or high intensity interval training, CrossFit type workouts. You don't want to do more than 2.5 hours a week of that type of exercise. There's diminishing returns or negative impact after that time period. But again, with zone 2, there's been no diminishing return point found. So you could do this as much as you want. And recommendations are general recommendations. This isn't my recommendation for you, but general recommendations are, if you don't exercise, the first goal would be to get to 2 hours a week of zone 2, which is pretty easy. That's 20 minutes a day. And then the next goal would be to get to 4 hours a week, which is about 40 minutes a day. And then again, you could build from there because there's no upper limit that's been discovered yet. And actually, the more of it you do, the healthier you'll be, the greater you're building your aerobic engine, and the longer you can go. So do the simple equation, 220 minus your age, that's your max heart rate. If you don't want to do the math in your head, you could grab a calculator and multiply your max heart rate by 0.6, and that'll be your low end number, and then 0.7, and that'll be your upper number. Then you want to stay between that range for your zone 2 exercise.
Dr. Bartemus.
Yep.
Okay, it's Maria. I have my NASM book out, and I'm confused because it says zone 1 consists of a heart rate of approximately 65 to 75 of a predicted heart rate max.
So there's there's a couple different schools of the heart rate training. So
Okay.
don't worry about what zone they're calling it. Just be between the 60 to 70%.
Oh my God. Okay. I'm glad I asked you that because this is driving me crazy. Okay.
Yeah,
So it doesn't matter what they're calling it,
yeah,
because if anyone else looks this up, this is out there.
yeah.
All right. So
Yeah, that just
60
like,
to 70.
yeah, yeah. There's different classifications and categorizations of things everywhere, right? So don't worry about the zone 1 or 2 so much as the percentage. So it's shoot for 60 to 70% of your heart rate, and you're doing what you're wanting to do.
Of my heart rate max.
Yep.
Okay. All right. Thank you for that. I appreciate it.
Yeah, you're
So
welcome.
basically, I have to put a big X in my book.
Well, how many zones do they say there are? Because some say 5, some say 4, so that can change like the brackets
Well,
and where they're.
yeah, this is just divided into 3.
Okay, yeah, so they have to take the whole 0 to 100% and break it up differently than if there were 5. So yeah, again, that's why we want to default to the percentage. Don't worry about the zone that they're calling it.
Okay. Thank you.
Good question, because we wouldn't want that technicality to stop you from working out properly.
Well, that's, I had a study and these were the answers. So
Yeah,
that's why I wanted to clarify it. Thanks again.
There's a lot of toxins in our food
oh yeah,
that the ultra processed and the processed food. And a lot of that contributes to our illness.
absolutely. And it's actually, I did a talk this weekend. I went to a local CrossFit and worked out with them, and then talked about functional medicine with them after. And I was talking about the toxin component and saying how there's been studies of fetal cord blood, and they find over 200 toxins in fetal cord blood. So my point of sharing that was, hey, we're never going to be toxin free. So we have to do the best we can, you know, given the world we live in. And same idea with the food. It's like that with each day that passes, we're getting further and further from being able to find unadulterated food, unfortunately. So it's working towards what's the cleanest we can do with what we've got. So for example, I mean, there's glyphosate found in the air and water everywhere on the planet. So even when we think we're eating the cleanest nutrition, it's probably still adulterated with glyphosate in some way. So it's yeah, I have to label these and number these because we're humans and we speak linearly, but just like we can't necessarily separate your blood sugar out from your inflammation, from your gut, from your mind state, we can't separate toxins from nutrition either. And that can reinforce the importance of the exercise, because one way to help clear toxins and minimize the damage of the toxins we're inevitably consuming is to detoxify them and clear them from our body. And exercise is going to help us do that through sweating.
Yeah.
So yeah, good point.
Yeah.
Dr. Bartemus, did you recommend about 20 minutes in that zone?
To begin with, yeah, shooting for 2 hours a week, which would be 20 minutes a day at first. Yeah.
Thank you.
And then 40 minutes would be the next goal, to hit 40 minutes a day. And
Wow.
yeah, and I'm going to change colors here, but to piggyback a little bit on what I was just saying with Sarah's question and detox. So sleep is important for recovery, but one thing that's really important from sleep is we get a brain detox when we sleep. And this is from a recently discovered mechanism called the glymphatic system. And this is only discovered about 3 or 4 years ago now, I think. And so what the glymphatic system is it's a lymphatic drainage system in the brain that was recently discovered. And when we sleep, the glymphatics clear toxins from the brain. And one of the major things it helps clear is beta amyloid plaquing, which are the plaques that build up in Alzheimer's, and alpha-synuclein plaques that build up in Parkinson's disease. So, not only is sleep deprivation acutely making us more inflamed and making us less healthy, but if we're not sleeping well and getting that good lymphatic drainage on a regular basis, that can be increasing our risk of neurodegenerative disease due to buildup of those protein aggregates. So you want to get your sleep, your optimal sleep.
How often would you recommend detoxing? And how would you recommend doing that with the glutathione?
There's lots of different ways. So I would recommend you detox every day through exercise, zone 2. I'd recommend you detox every night through sleeping lymphatically. Glutathione would be an excellent supplemental encouragement of detox because glutathione is our body's master antioxidant and the liver uses it a lot to do its job. So yes, optimizing and sustaining your glutathione levels is going to be important for detoxing. You can do near infrared saunas to detox. Obviously, healthy nutrition is going to help you detox, and the brassica family that is high in sulfur. So broccoli, cabbage, cauliflower, kale, bok choy, those types of veggies have a lot of sulfur, and sulfur is key for the production of glutathione. They also, broccoli contains sulforaphane, which is a powerful antioxidant and detoxification agent. So yeah, there's many ways to detox, and if you're living a healthy lifestyle, you're actually detoxing daily without having to think about it because you're, doing the activities that naturally detox you, and that's the best way because it becomes second nature for you. And then you can save the whole, detox cleanses or the special stuff for when life happens and you had an acute exposure to something that needs to be detoxed, say.